Now we will take a look about the indifference curve. What is an indifference curve? Imagine you are hungry and you like pizza and soft drinks. You don't always need the same amount of both. Sometimes you may prefer more pizza and less soft drink, less pizza and more soft drink. As long as you are equally happy, you don't mind which combination you get. This is exactly what an indifference curve shows. Definition in simple words. An indifference curve is a line showing different combinations of two goods that give the same level of satisfaction to a consumer. The word indifference means I don't care which combination I get because both make me equally happy. Daily life example: pizza and soft drink. Suppose these combinations all make you equally satisfied. You are equally happy with all four combinations. That means all these points lie on one indifference curve. What is an indifference map? Now imagine not just one indifference curve, but many. Some curves represent normal happiness, some represent more happiness, some represent maximum happiness. The collection of all these curves is called an indifference map. Properties of indifference curves. Let's understand them one by one. Number one, indifferent curve slopes downward. Why? If you have less pizza, you need more soft drink to remain equally happy. Example: 5 pizza, 1 soft drink. 4 pizza, 2 soft drink. 3 pizza, 3 soft drink. One decreases, the other increases. Therefore, the curve slopes downward. Think of a seesaw: pizza going down, soft drink going up. Indifferent curve slopes downward. To remain equally satisfied, less of one good can be compensated by more of the other. Daily life example: suppose your mother gives you 5 slices of pizza and 1 juice. Tomorrow she gives you only 4 slices. You'll probably ask, can I have one more juice? More juice compensates for less pizza. Number 2. Indifferent curves are convex to the origin. This sounds difficult, but it is actually simple. Imagine you have lots of pizza but only one soft drink. You will give away some pizza for another soft drink. But if you already have many soft drinks, getting one more soft drink isn't as exciting. So, the more of one good you have, the less extra satisfaction you get from additional units of it. This is why the curve bends inward. This shape is called convex. Daily life example: imagine 10 chocolates, 1 ice cream. You may happily exchange 2 chocolates for 1 ice cream. But later, you already have 5 ice creams. Will you still exchange 2 chocolates for another ice cream? Probably not. This changing willingness makes the curve convex. Number 3. The slope of the curve is called marginal rate of substitution. Don't worry about the big name. It simply means how much of one good are you willing to give up to get one more unit of another good while remaining equally happy. Example: suppose you have 5 apples, 2 oranges. You are willing to give up 2 apples to get 1 extra orange. Your marginal rate of substitution is 2 apples for 1 orange. Daily life example: suppose you love both tea and coffee. Today you may happily exchange 2 cups of tea for 1 cup of coffee. That exchange rate is your marginal rate of substitution. Number 4. Higher indifferent curve means higher satisfaction. Suppose curve 1, 2 burgers, 1 cold drink. Curve 2, 5 burgers, 3 cold drinks. Which gives more happiness? Obviously, curve 2. Therefore, higher curve is equal to higher satisfaction. Think of climbing a hill. The higher you go, the better the view. Similarly, higher indifferent curve is equal to more happiness. Daily life example: imagine curve 1, 2 mangoes plus 2 bananas. Curve 2, 5 mangoes plus 5 bananas. You will clearly prefer curve 2 because you have more of both goods. Number 5. An indifferent curve never touches the x-axis or y-axis. If it touches the x-axis, you will have only one good and zero of the other. Normally, consumers prefer having some quantity of both goods, so the curve does not touch either axis. An indifferent curve never touches x or y axis because consumer generally wants some quantity of both goods. Daily life example: imagine 10 cups of tea, 0 biscuits. Most people would rather have 9 cups of tea and 2 biscuits. Having only one good is generally less preferred. Number 6. Two indifference curves never intersect. This is very important. Imagine curve A means happy, curve B means happier. Two indifferent curves never intersect each other. If they intersect, one combination will give two different levels of satisfaction, which is impossible. If they cross, one combination will have to give both happiness and greater happiness at the same time. That is impossible. So, two indifference curves can never intersect. Daily life example: think of your favorite meal. Suppose today your mother asks, which dinner do you like? Meal A: chicken, rice, and juice. You say, I am 100% satisfied. Tomorrow, she gives you meal B: chicken, rice, juice, and cake. You say, now I am happier. Meal B gives more satisfaction than meal A. Now imagine someone says, meal B gives exactly the same satisfaction as meal A, and also says, meal B gives more satisfaction than meal A. Can both statements be true? No. That's exactly why indifference curves cannot intersect. Remember the key idea. An indifferent curve shows different combinations of two goods that give the same satisfaction. An indifference map is a collection of such curves, where higher curves represent higher satisfaction.